Okay, so you would have seen in the previous video from Sal Khan the proof for where this change of base formula comes from. What we want to be able to just recognize when looking at this, just kind of what our different values A, B, and N stand for. So if we have some logarithm we're trying to evaluate, like in example 5, we're trying to evaluate log base 2. So 2 is our A value. That's our base of the logarithm. So we're saying 2 to what exponent, right? What number are we going to get over here? Is it going to be to the 5th power, to the 5.5 power? Is it going to be third power? What is the exponent by which we can raise 2 by to get a value of 11? In order to evaluate that using the tools we have access to, the tools which is the common logs that we get when using the calculator, log base 10, we go through this formula. So we say we're going to do log base 10. Now it doesn't have to be base 10. This can be a formula that moves you through any base to any other base, but generally we are going to be trying to turn things that are not base 10 into base 10 so that calculators can use them. Now there could be other situations where you want to go from base 2 to base 3 or base 2 to base 12. This would do the same thing, but for now we're going to try to move from base 2 to base 10. Okay, so you take your old base, and the solution to this logarithm is going to be your new base with the original number applied to it. So log of n using log base 10. So log base 10 of whatever value you were trying to evaluate. So in this case, it was 11, right? So we're going to say log base 10 of 11. And that's going to be divided by log base 10 of the old base. Okay, so it's not too hard to remember. So if you look at this, if you're trying to change from base 2 to base 10, you just say log base 2 equals log base 10 divided by log base 10 of 2, right? So the only thing that you have to add on is just divided by log base 10 of your old base. Okay, so this has a whole lot of letters in it, and it can look a little confusing, but the actual steps you go through is not too complicated. So for example, let's do a different one than they're showing. If we wanted to go from log base, let's say we want to say 3, and we'll do 28. Okay, so we know that 3 to the 3rd power is 27. So our answer here should be, roughly, I don't know, 3.1 or something. That's kind of our expectation. Should be a little bit bigger than 3. The way that we would evaluate that, we would say we want to put it in terms that our calculator is programmed to use, so log base 10. So we'll say log base 10 of 28, and then we'll divide that by log base 10 of 3. Okay, so that's all that's to it in order to switch that around. Now, if I take that, let's go over to calculator and see what we get. I'm going to say log of 28. They're assuming that's log base 10. And I'm going to divide that by log of 3. Let's see. Here we go, 3.033. So a little bit larger than 3, just as we estimated. I estimated 3.1, a little bit too big, but the general idea was still there. Okay, now on this example, they go through that and they find that, well, let's just look at this and think about like what we'd estimate this to be. So 2 squared is 4, 2 cubed is 8, 2 to the 4th power is 16. So it should be somewhere between the 3rd and the 4th power. I'm expecting that this answer, when you put it in the calculator, is somewhere between 3 and 4. And there we go. Yes, it is, right in between 3 and 4. Cool. On to the next one.